Okay, now we're going to move on and carry out the operations of multiplication and division. Now, the good thing about multiplying and dividing is you do not have to have common denominators. You can just multiply straight across. So when I am multiplying here, I can just multiply straight across. 2 times 4 would be 8, and 3 times 5 would be 15. Done deal. No big deal. Okay, on this next one, I'm going to multiply straight across, and 2 times 6 is 12. 3 times 7 is 21, and I'm hoping that we recognize that both of these are multiples of 3, so I can divide both numerator and denominator by 3 to get 4 sevenths. So I will have to reduce my answer. So I want to point out here, it looks like I've copied the same problem, which I did, but I want to show you a shortcut. See, here you were multiplying to get larger terms just to turn around and divide back down to smaller terms. What I want to point out is that you can reduce before you multiply to keep your numbers small. So you're recognizing diagonally that I've got multiples of 3. So I can divide this denominator by 3, which would give me 1, and this numerator by 3, which would give me 2. This way I'm keeping my numbers small before I go ahead and multiply. 2 times 2 would give me 4. 1 times 7 gives me 7, and I get my answer, and I don't have to reduce. And this next one, we can reduce diagonally both ways. I can reduce 5 from this denominator, which would leave me 1, 5 from this numerator, which would leave me 5. Looking at the 6 and the 12, I can reduce 6 from the numerator here, which would leave me 1, 6 from this denominator would leave me 2. So I end up with 1 times 5 is 5, and 1 times 2 is 2, so I'd have 5 halves. So yes, I'm going to have to reduce this. 2 goes into 5, 2 times with 1 half left over. Now this next one, we've got 3 fractions that we are multiplying. We can see that we can reduce diagonally here. 3 divided by 3 is 1, 3 divided by 3 is 1 here, so we reduce 3 from the numerator and 3 from the denominator here. Now, the first and the last fraction are both they have multiples of 2. So I can reduce this denominator. 8 divided by 2 gives me 4. 6 divided by 2 gives me 3. Now I don't see anything else that I can do, so I can go ahead and multiply straight across. 1 times 5 times 3 is 15. 4 times 1 times 7 is 28. And there we are. Okay, moving down here, we're going to recognize that we can carry out division by converting it to a multiplication problem. So what I want you to recognize is that you are going to be, well, just remember the stays, change, flip to convert this. The first fraction stays as it is, so I'm going to write an arrow here saying we're doing a conversion, or rewriting the problem. So 4/3 stays as is, but our sign is going to change to multiplication, and what we're dividing by, now we're going to be multiplying by its reciprocal, which would be 2 sevenths. Not anything that we can do here to reduce, so we're going to end up with 4 times 2 is 8, 3 times 1 is 21. On this next one, again, stays, change, flip, and rewrite this as 5/4. Our sign changes to times, and we're going to go with 2/3, the reciprocal, flipping this one. So here I can reduce. 4 divided by 4 is, 4 divided by 2 is 2. 2 divided by 2 is 1, so I'd have 1 times 5 is 5, and 2 times 3 is 6. Okay, this next one, it looks kind of intimidating, but it's really a complex fraction where we're taking a fraction divided by a fraction. So we can look at this as top number divided by the bottom number. So basically what I'm saying is 2/9 divided by 5/12. So I'm just rewriting it in a way that I recognize, but then I can apply the stays, change, flip, which would be 2/9. This is going to change to 12/5. Now I can recognize diagonally these are multiples of 3. So 9 divided by 3 gives me 3. 12 divided by 3 gives me 4, and we end up with 8/15. Okay, on this row we can recognize that when we're dividing by a whole number, it's like we can write that whole number as a fraction. So this would convert to 7/8 times 1/14. We can reduce diagonally. I've got some patterns going on here. That doesn't always happen. We end up with 1/16. I'll let you work on that one. This next one, we need to recognize that again. I can write a whole number as a fraction. by writing it over 1. So that would convert to 36 over 1 times 5/4, and 9 goes into 36, I'm sorry, 5 goes into 36, sorry, 4 goes into 36 9 times, and this is going to leave me with 45. I'm realizing I don't have a problem on here where I had mixed numbers, and I guess I want to make one up and do this with you. If I had something like 1 and 1/3, okay, I'm going to make this a multiplication problem, multiplied by 2 and, oh gosh, I don't know if I'd make that 5/8. And I want you to recognize that with mixed numbers, you need to change those to improper fractions before you can carry anything out. So I'm going to multiply this. 3 times 1 is 3, plus 1 more would be 4/3, so that would be 4/3, so I'm rewriting that as 4/3. This one I'm going to rewrite as 8 times 2 is 16, plus 5 is going to be 21, and that would be 8ths. And lo and behold, I happen to make one up that I can do a lot of reducing. So diagonally here we have multiples of 3, so I'm going to divide by 3. And diagonally here we have multiples of 4, so I'm going to divide by 4. We end up with 7/2. That again, I can convert this back to a mixed number, which would give us 3 and 1/2. So I just want you to remember that when you are multiplying or dividing with mixed numbers, you will need to convert them to improper fractions to get them in that fraction form so you actually can carry out the multiplication skills or division skills.